This video is about tolerance stackups and how tolerance stackups can affect how we interpret drawings or how we dimension drawings. I have 4 instances of the same part, a plate with 2 holes in it, and I've dimensioned it 4 different ways, partially dimensioned it. Of course, these are not fully dimensioned drawings, but I've only included the dimensions relevant for this discussion. So in this part right here, I have chain dimensioned the part. This part, I have datum or baseline dimensioned the part. And in this drawing, I have these 2 drawings. I've actually done a combination of both. So let's look at what this really means. Are these all equivalent or are they not? So looking at the first drawing, the chain dimension drawing, note all dimensions are 2 decimal places. That means that all tolerances are plus or minus 0.01. So let's think about looking at this drawing and considering the dimension A, the space between the holes. What is the tolerance on the dimension between the holes? Here it's pretty straightforward. It's plus or minus 0.01 because the distance between the holes, distance between centers, is directly dimensioned. If we move over to this part, now that I've chosen to baseline, the same cannot be said of dimension A. Note that this dimension can be as small as 0.99, and this dimension can be as large as 2.01. That means that the distance between the holes could be as much as 1.02. Similar logic, this dimension could be as large as 1.01. This dimension could be as small as 1.99. And in that case, the dimension between the hole would be 0.98 or 0.02 under. So the difference between this drawing and this drawing is that the tolerance on the distance between the holes is very different. It's plus or minus 0.01 here, plus or minus 0.02 here. Now let's think about dimension B, the width of the plate. In the chain dimension drawing, this dimension could be as large as 1.01. This dimension could be as large as 1.01. And this dimension could be as large as 1.01. Which means the total width of the plate could be as large as 3.03. And similar logic, the plate could be as small as 2.97. So according to this drawing, the tolerance on dimension B, the outside of the plate, is plus or minus 0.03. Moving to the datum dimension drawing, what is the tolerance on B? Well, B here is directly dimensioned to be 3.00 plus or minus 0.01. So how you choose to dimension makes a very, very big difference in exactly what you're specifying. Moving to the third part, I've used a combination. So let's examine the same thing. Here, the distance between the holes is directly dimensioned, so its tolerance is plus or minus 0.01, and the distance between the outside edges, or the width of the plate, has been directly dimensioned, so its tolerance is plus or minus 0.01. Ultimately, the designer needs to dimension according to what's important about the part. If the dimension between the 2 holes is critical, and the outside dimension of the plate and the location of the holes within that plate isn't that important, this is an okay way to dimension. If the outside dimension of the plate is critical, and the distance between the holes not so critical, this is an okay way to dimension. If, however, they're both critical, this drawing is telling me that the dimension from this edge to the center of this hole is important. The distance between these two holes is important. And the overall width of the plate is important. Finally, let's look at the last drawing. This drawing has been over-dimensioned and is absolutely incorrect. As before, if we look at dimension A, it's directly specified, so no problem. We understand that the tolerance for the distance between the holes is 0.01. However, we have a conflict on the outer width of the plate. If we look at these dimensions here, it tells us that the tolerance on the outside of the plate is plus or minus 0.03. If we look at this dimension instead, it tells us that the tolerance is plus or minus 0.01. And the two are mutually exclusive. It can't be both. So this is absolutely incorrect. This is the major problem with over-dimensioning, is it leads to ambiguity in the tolerances and what's important about the part. We can correct this drawing. We can edit this dimension and put parentheses around it. We'll zoom in. Now this drawing is okay. The parentheses around the dimension indicate that this is a reference dimension and that tolerance do not apply to it. A reference dimension is for information only. I wouldn't do that on this part because the math is so simple. But if you had a part where the math wasn't quite so simple and you wanted to give the manufacturing folks some help in understanding or not having to break out their calculator to figure out what this dimension is, then this is okay. Another way to do this, the parentheses are actually the current way of doing this. The older version of the drawing would say the older drawing standard would look like this. This dimension would actually be marked with ref for reference. You're not training to be draftsmen and draftswomen, so whichever you use is really up to you.